Hey, Math 30-2. So today we're going to be talking about probabilities in using counting methods that we learned back 2 chapters ago when we talked about permutations, combinations, and we used the fundamental counting principle to do so. So like putting people in order when you take their picture, or taking a bunch of people and then putting them to a committee and maybe limiting or producing passwords where you only have letters and numbers and you can't repeat or something like that. And now we're going to use that in kind of a probability context. Before we do so, I want to talk about this warm-up question, the Monty Hall problem. So the Monty Hall problem is a famous mathematical problem. I'm just going to highlight these 2 YouTube videos down here as well. It's a famous mathematical problem that's confused mathematicians around the world. It's probably older than this problem actually states, but this is based on a TV show called Let's Make a Deal, hosted by this guy named Monty Hall. So that's why it's called the Monty Hall problem. In this scenario, you have 3 doors, and behind the doors, there's some prizes. 2 of them are like goats, so they're prizes you don't want, and one of them is the main prize, the trip to Hawaii or a car or something. So how it works is that you are the contestant, and you're going to choose one of the 2 doors, or one of the 3 doors there, 1, 2, 3. Okay. And you're going to choose a door, and what Monty's going to do, say you chose door number 1, he's going to choose another door, and he's going to open that door up to reveal what's behind it. And it reveals behind it a goat. And he's always going to reveal a goat. He's not going to choose a door at random. He knows what's behind the doors, so he's going to choose a door that has a goat behind it. Then you have the option at this point, either stay at the door that you picked originally or switch to another. All right? Now, the problem is, what is the probability? Should you switch to the other door, or should you stay at the door that you're currently on? That's the goal to figure out. Okay, so if you haven't done so already, watch these 2 videos down here. One is a Brooklyn Nine-Nine video. You can just go to the notes, the PDF version, and click on the links there, or you can type in this little code here after watch here, and you can see these 2 videos. So one's a Brooklyn Nine-Nine, doesn't really help us too much, it's kind of funny. And then the other one is a number file video that gives a better description, and then it tries to give you the answer. I think it's a good way to describe it. It talks about what the actual answer is. So if you haven't done so, go ahead and watch those. If you have already, that's great, then you already know the answer. The answer is, it's not a 50-50 like most people would say, like, oh, I'm going to stay here, it could be a car or a goat, or I can go here, it could be a car or a goat. So it's like a 50-50 chance. It's actually more favorable, a 2/3 chance to switch. So to figure that out, let's talk about how we solve problems about probability already, and how we solve them is we think about our sample space. So I want to think about this, I want to think my sample space. Okay? And then I want to think about, what are the odds of winning if I switch, and what are the odds of winning if I stay? I want to compare the 2 odds, right? Or not really odds, but probability. So I want to do the winning if I stay, or what is the probability of winning if I switch? Okay? So that's what we're going to try to figure out. Okay? Now, to do the sample space, we're going to have to go through each one of these doors and just think about all the different situations we can do. So we choose door number 1. I can, if I choose door number 1, Monty Hall is going to either open door number 2 or 3. So he's going to open a door, and then you're going to have the option of switching or staying. Okay? Now, in this case, if I said stay, you'd win the car, right? The car's behind there. If I switched and say you open door number 2 here, or door number 3, it doesn't really matter because both have a goat. Say I pick this door over here, I'd have a goat behind it, and I'd lose. So switching would mean I lost, and then staying would mean I win, right? So far I have 1 loss for switch and 1 win for stay. Now, we're going to do the same thing. We're going to choose door number 2 this time. Then you have an option to switch or stay after Monty Hall opens the door. So if I chose number 2, Monty Hall is going to open door number 3 because he knows there's a goat there. So if I stay on number 2, I'm going to lose because there's a goat behind that door. If I switch to number 1, I'd win. I get the car. So if I switch, I win. Okay? And then if I stay, I lose. So right now I have, if I switch, I win or lose. So it's a 50-50 chance right there. If I stay, I win or lose, depending on the situation I have here. So it's a 50-50 chance. So hopefully this last one will fix this, right? So if I pick door number 3, I can either switch or I can stay. Okay. So if I pick door number 3, Monty Hall would open door number 2, reveal the goat, and then you could stay on door number 3. So if I stay on door number 3, I got the goat again. So if I stay, I lose. But if I switch, I win. I get the car. So I win. Cool. Okay, so now what we're going to do is we're going to look at this. So I want to know what's the probability of me winning if I stayed. So I have an event. I stayed on my door. So these are what we call mutually exclusive events. They depend on each other. So if I stay, what's the chances of me winning? So I look at my events where I stay. I stay here, and I stay here. Okay? So I look at that and I say, okay, that's my sample space. I have 3 things. So my sample space is 3. Okay. Sample space is 3. And the chances of me winning is only one of the 3. So it's 1/3 chance of winning if I stay. Now if I switch, I'll move this out of the way. There you go. If I switch, I either lose, I win, or I win. All right? So that means my sample space is 3 again. So I have 3 things where I can switch here. But I win 2 out of the 3 times. So based on this logic, you'd want to switch. It's a 2/3 chance of you winning if you switch. Not a 50-50, like most mathematicians would say. So you'd want to switch in this case. Based on what our sample space says and based on all the outcomes, you have a 2/3 chance of winning versus a 1/3 chance of winning if you stay. So always switch when you come to this kind of conundrum. Okay? The next video will actually start the real lesson. I'll see you then. Bye.